What I'm here to present today is basically Cardinal's low E options and code compliance. And he's done a really good job at going through the code. So I'm going to go through the low E options and therefore go through which products actually comply through Strasburger's 3000 operable casement program. And then we'll open it up to some questions. I do as well have some performance data sheets that are available to you, believe through perhaps on a USB stick or a handout that we can get out to the folks. But it'll give you all the different combinations of Cardinal's low E products in both a dual pane and a triple pane construction, because as we know, triples are becoming very prominent and they're going to be coming very soon. So once again, I just went through the introduction. We'll go through the low E products. Code compliance, or the review anyways, I'm going to kind of gloss over very quickly as at the risk of seeming redundant over the past two speakers. But we'll get into the compliance. We'll look at the performance data, and then as well as that, we've got a couple of future products that we're just awaiting patents on. I don't have actually the material on it just yet, but I can speak towards it a little bit, and so we'll discuss that as well, and then we'll open it up for questions. Here we have Cardinal's low E products. The most prevalent ones that we have here in Canada are going to be low E 180, low E 272, and low E 366. That is also coupled with a fourth surface product called low E I-89. Basically how Cardinal goes about naming their products is that the first number out of the series of three is the layers of silver, and the second two numbers is the visible light transmission. Low E 180, essentially this is a product that we basically had to bring back from the dead. It was all in an effort to comply to Canada's energy codes. As such, because it's a single silver product, we actually mothballed it, but had to re-engineer it to comply to the codes. It offers great passive solar gain in the summertime, but as was discussed a little bit earlier on by Andy, in the wintertime, that passive solar gain is going to actually cost you on the heating side. But because of our current ER system, this is what complies to the standard. Low E 272, obviously it's 2 layers of silver and 72% transmittable light. I would have to say this is Cardinal's highest volume product. The reason behind that is because it offers basically year-round comfort. You're going to have high energy savings in the summertime as well as the wintertime, and it's a comfortable R4. When you look at low E 180, it gets into almost the it's almost an R 3.8. Which is pretty good for a single silver product, but once again, it's not going to offer you the same kind of year-round comfort as low E 272. Low E 366 is based in U value. It has its place in the southern states, and a lot of say dealers that take the time to educate their customers or their clients relative to performance and the value in U factors have moved towards this. It's a great product that has a high U value. It is actually a 0.24. When you, I guess, relating back to Andy's comments, with the triple panes are coming very quickly, I just wanted to kind of take a moment and explain that the common thought process, I guess, in the glass industry is that a triple pane performance is basically valued at a 0.2 U value or an R5. When we take a look at the performance data, or I can just speak about it now a little bit later, is that we can offer through Bob's program and through his casement series or any of his products and get you an R5 in a dual pane performance. So if you use low E I-89 on surface 4 and then low E 366 on surface 2, that actually nets you an R5.1. So essentially you're getting a triple pane performance in a dual pane construction. Because and I'm sure Bob and his engineers and his production people can speak towards this, but the triple pane is actually very heavy. It's hard on the hardware. A lot of other folks are different, say, profiles have a hard time getting to that overall thickness as well. But I-89, essentially what it is, it's a room side low E. It's made of indium, which is mainly mined in China. Our first kick at the can at this product was called actually I-81. The performance value of it is exactly the same as the I-89, but the difficulty what we had with this is that there was a high room side reflectivity, as well as that I'm sure some of you have seen this before, we had some difficulties with condensation. Now that's very common for any kind of room side product or a pyrolytic. So what we did is we went back to the drawing board and we re-engineered it to basically drastically reduce the condensation and the reflectivity. So therefore, we've got this product now on the market, whereas we can couple it with Lowy 366 and actually Lowy 270 to get you an R factor of 5 and a triple pane performance. When you look at basically, as I spoke to like a pyrolytic beforehand, and you look to I-89, the center pane that you see is actually I-89. It is very, very clear. It's an 89% visible light transmission. And when you look at pyrolytic glass, because the pyrolytics the Lowy properties are baked into it at the float glass level, there's a lot of impurities. So you kind of get a milky appearance, and that's clearly evident to the example that we see here on our screen. Once again, Andy's done a real nice job with the code review, so I'm going to actually skip right to the compliance, but I'll stop right here. The new energy or the energy zones in Ontario are basically comprised of Zone 1 and Zone 2. Predominantly, we are all living in Zone 1, and that basically means there's less than 5,000 heating degree days per year. Now, once again, relating back to Andy's getting a lot of play here, but when he had spoken towards the new standard being at 1.4, that's a 0.25 on the U value, and Cardinal, as within Strasburger's window systems, has you well covered moving forward. So what complies? I took the test data from the NFRC of the operable casement on the 3000 series. And out of the 36 combinations that we have tested within Strasburger's program, only one product does not comply, and that's the dual pane 366. The reason behind that is because the U factor of it, and it doesn't meet the minimum ER standard. So once again, you're well covered for the new codes moving forward. Once again, these are the performance data that's going to be available to you. And I'll open up the room for questions. But before I do that, just want to kind of go through some future products. And once again, I don't have these slides on them just yet because they're under patent. But I know a lot of folks get, I guess, concerns or complaints from their customer base relative to having condensation on surface 1 of the glass. That's, an atmospheric condition that's, essentially out of anybody's control because that's physics in the atmosphere. But nonetheless, we've come up with a recipe. The product's actually going to be called X89, which will go on the surface of surface 1, and it will drastically reduce the condensation time of any exterior pane glass. So if you kind of put it, or if you're looking at comparison between, say, the dew on your grass or the dew that is on the windshield of your car, the dew that will be on the window with this new product on it would be drastically reduced and dry a heck of a lot quicker. The next product that I'll speak towards, and this is kind of exciting because we're going to try and tap into an industry that it's basically window and fenestration covering, so blinds and draperies and such like that. It's an $8 billion market per year. We've developed a technology called Click, and essentially what it's going to enable us to do is that it's a product that you can control with your smartphone or remote within your house, and that it will enable you to actually make your window go opaque or different colors, or you can make a grill pattern, or you can actually make it an appearance of blinds. So gone are going to be the days where you have to look at getting the mini blinds that are in between the panes of glass, because the first thing that these manufacturers do when they do that is that you got to poke a hole through the spacer, which basically promotes a seal failure in the first place. And I've seen many examples whereas the blinds just fall. So this product is about 12 to 18 months out. We do have working prototypes and we do have patents in place, so we're just working on the refinement of it. So with all that said, once again, thanks to the Strasburger family for having me in, and I'll just open the floor up if you have any questions.
When designing a house, are the builders going to have to put 4 different kinds of low E in for all the different exposures, north, south, east, west?
You can do that. Right now, it's not required to, but I fear with the new building codes that are going to come in conjunction with the Energy Star, I don't know if it's going to exactly match up, because some elevations are going to require, say, a coating that may not meet both the U value and the ER value, because it's got to meet up under that prescriptive value. So to answer you right now, until I see the new code come out, I can't give you a definitive answer on that one.
So what is the best, our best low E coating we should be recommending?
In my mind, it's low E 272. And in the advent that we do move more quickly towards the triple pane product, the low E 270 and the I-89 will give you that R5 factor. So it'll give you that triple pane performance in a dual pane construction.
So the 272 is
it's a variation. Yeah, exactly.
So it's going to be kind of milky?
Pardon me?
Is it going to be kind of milky?
No, actually, because our products they're not done at the float glass level. Like all our low E products are sputtered on at one of our coating facilities. So it's the clear glass that comes out of the float plants and then goes to one of our coating plants, and it's actually molecularly sputtered on. So the appearance of it is very clear. When you get into, say, pyrolytics, that's when you kind of run into those milky properties, because number one, there's imperfections in the glass, and number two, there's a very high surface roughness to it. Like if you ever touch a pyrolytic glass, it's actually, or try to clean it with a say like a paper towel type thing, it'll actually shred it. So that's where you're getting your milkiness in the photo that I showed you there before.
Thank you.
No problem.
Will that click technology require low voltage?
Well, see, this is why we're still about 12 to 18 months away right now, because we're trying to decide how we're going to go about powering it. Because there's a couple of different options that you can go through. It's either the low voltage, or if we actually do it in a new construction basis and get it wired in type thing. So this is why we're doing the hold up right now. We've got the working product on how it performs. It's just that how are we going to power it now? That's the dilemma.
On a double pane window, and you put your low E coating on surface 4, what about the risk of damaging that when you clean it? I know you can't use abrasive, and you can explain to the customer, hey, no abrasive, but when that house sells, that probably won't be communicated to the next owner.
No, the I-89 acts as the same as, you can clean it the same as actually clear glass. So like a regular Windex or anything that's non-abrasive, it perfectly works on it. The reason why you can do this, even although it is a low E product, is because the property or the element in it is indium, which does not corrode. When a typical low E has moisture on it, because a large part of it has to do with silver, that's where you get the corrosion and, say, the scratching occurs. And actually, to give you take it a step further, the I-89 has a 10-year warranty on it as well.
What about the 270 and the I-89? What surface is the I-89 on?
The I-89 is room side, so you'd be able to touch it. But let me I guess let me explain to this, because you're probably thinking that it's got a tint to it or something like this. When you look at the say the visual aspects of clear glass itself, it's at the visible light transmission is at 83%. This is actually clearer than the clear glass. It's 89. If you take all the impurities on, and it's almost a low iron glass. So that's how we're able to keep the I guess the tint and the reflectivity out of it.
Will there be some kind of warranty, or is there a problem with this I-89 coming off and delaminating off the glass?
No, it's actually it's molecularly bound, just like a low E product is. So when when you coat glass, I guess on the atomic level, we put it through our assemblies. It's basically your clear glass is floating through essentially space. So there's a bunch of molecules that are bouncing around, hitting off targets, and then when it hits those targets, say like indium or silver or titanium oxide, it bounces and reflects back up onto the glass. So it actually bonds right onto the glass itself.
Yeah, quick question. The condensation resistance factor for your typical low E 180 Surface 3 compared to the I-89? What are the numbers?
They're not the same product though, because one's an exposed product and the other is not.
But what is the condensation resistant numbers between the two?
Well, on the I-89, it's higher than the low E 180,
Okay.
simply because you're going to get it around the corners. I don't have the exact number in my head, but I can forward it to you, and if you should
Okay,
like, yeah.
no, that's good.
I have a question just for clarification. When I was hearing from Andy, it's all about triple glazing, but then when you spoke, you saying Cardinal has Strasburgers covered for on the double glaze.
Well, what I'd stated is that in the industry, typically what an R5 means is triple gaze performance value, okay? So an R5 is 0.20. To achieve that, typically people would have to go to a triple paint construction with two low E products, one on surface 2 and one on surface 5. So essentially what Cardinal's doing is that we're still having two low E products, but it's in a dual paint construction on surface 2 and surface 4. So if you look at, say, what I-89 is adding to the table, I guess, on the U factor side, is that essentially it's giving you a reduction in U value the same as a 90% argon fill is. So if you take low E 366, which is at 0.24 on the U value side, you're going to get that extra kick, which will from the I-89 will bring you down to 0.196. So 5 point.
That's a lot of numbers.
The short answer is the result of the combination of the two and the dual paint with the I-89 is an R5.1, whereas the threshold is R5.
Okay, so we are covered.
Yes.
All right, thank you.
I just have a question about neat glass, and I'm wondering if you can explain it. We've put it on a few windows, and we've had a couple of customers say it works, and others are complaining about it because they still have to clean their glass. Can you just clarify the product a little better for us?
Well, what the product is, and then there's kind of a common, I guess, misconception out there, and that's from prior products. Neat is not self-cleaning glass. It's low-maintenance glass. And what it is, it's titanium silicon dioxide that actually gets sputtered onto surface 1. Now, if you were to look at if you look at the normal glass under like an electron microscope, it's incredibly rough. There's high peaks and valleys. So what we're doing with the titanium silicon dioxide is that we're sputtering off to make that glass flat. Now, because of the properties itself, it actually has to be activated by the sun. And depending on the elevation of what your house is facing or what these windows are facing, they might not have been activated just yet. So without looking at the house, I wouldn't know how to properly answer you, but that's essentially what it is. It has to be activated through sunlight.
How long does it take to activate it?
Well, typically in a normal setting, it takes 2 weeks.
But with Canada Post, you never know.
So just a quick clarification, just the gentleman's question over here. So the 1.4, which is the building code, is the dual glaze, the 189.
Yeah, which is the 0.25.
So the building code is what's coming in 2017, and that's what we build so we don't go to jail. Okay, so the Energy Star program, which is 33% of our starts, which is changing, and the net zero requirements have U values of 1.1 to 1.2. In those cases, are you not fully into triples with your product?
Yeah, I believe so. The vast majority, yeah, if it gets, because I haven't seen the new code that's come out or it's coming down the pike with your net zero. So without taking a look at it, I shouldn't really comment on it just yet.
Yeah, it is.
But like currently of what we're seeing out in the market and the standards that we have, Bob's program is covered under that operable
Yeah.
casement.
So as those programs come forward, keep in mind with Energy Star changing in Ontario and across Canada, the net zero, they will be U values of 1.2 to 1.1, which the triple glaze that Strasburg currently has actually meets.
Yeah, well, of course. They shoot on the triple glaze offering that Bob has. If we do 2 coatings of 366 and then 1 coating of I-89, we can get down to 0.106. So like once again, either which way we would decide to go, he's well covered. Yeah.
As we move to triple pane units and we start putting multiple coatings on, are there concerns about heat gain within the unit and compromising the seal?
No, actually, yeah, we've came up for a solution with that. I just actually sent the material to my customer base about 3 weeks ago. On each of our insulated glass lines at the manufacturing level, like we design and manufacture our own equipment. We've got these stations, they're called ablation stations. And so that you can have the equalization, not the heat buildup, and which is going to cause, a catastrophic failure or thermal breakage. We actually have a laser hole that's drilled into the corner of the unit itself so that the air can equalize throughout the 2 chambers.
And what hasn't been mentioned is any sort of krypton or krypton blend.
No, the ARP, basically, because of the way that we go about filling our units, a lot of folks out there that manufacture units do called, what's the Lance system? So we do not do that. We have a vacuum system. Lance system's kind of gone by the wayside solely for the fact that you actually have to put probes into the spacer itself and poke holes through it. So we think that's a non-starter in the first place. And plus, 1 cycle of gas only nets you about 65% of the argon fill. But going back to the krypton, krypton's essentially very rare and very expensive. But that's not even the reason why we don't use it. Krypton's only basically useful in narrow airspaces. So like 5 to 8 millimeter airspaces. With the codes that are coming out and how units are currently constructed, the best performing airspace you can have is between 11 and 13 millimeters, so like basically a half inch. So when you get into those widths, the argon outperforms the krypton. Krypton essentially is just selling sizzle. When I see these ads on the internet or wherever, or in a magazine or whatever, and they tell me it's krypton fill, I kind of giggle about it because I know exactly what it is. It's a blend. It's about a friggin' 5 to 95% blend. Sure, they're going to send a full 90% filled krypton unit to get tested, but there's no chance on earth that they're going to be able to find that amount of krypton or be able to afford it. So it's selling sizzle, and the facts are, with the proper airspace, the argon outperforms it. Thank you very much.